Notes. I got no notes. Okay, guys. Welcome to Dimensional Game Theory. From chess to Unicode. Okay, guys, this info is very important to me. I want you guys to take it with almost dignity. It's not to diminish game theory as it is. It's to expand the horizon of game theory in the real world. You know, dimensional game theory is the real world's game theory. And it's based on dimensions. This project should cover all you need. Just to get started with dimensional game theory, but it's not to dismiss game theory, and it's all a formulation. It's all an extension of the game theory framework already here. It addresses real world problems in real world scenarios. That's the problem that dimensions have, the power of the dimension. Now, a dimension is something you define, to address this problem. I'm gonna give you the layman's explanation, and we're gonna go through this. Okay, so I got my here. Okay, basically here I got this. So my pen here, red, orange. So my this is my ink here. No, it's my pointer. So dimension. A dimension is in layman's terms, dimension is a problem you define or strategy you want to enforce in a game. You know, it's like red team, blue team. What's the red team strategy? What's the blue team strategy? Who's the advantage? Who's the disadvantage? In chess, there's attack dimension, defense dimension, and offensive dimensions. Now, these dimensions represent problems. I want to attack. I want to move a champion to attack. I want to set up an offense with a pawn. I want to give defense or defend. What is the strategy? There's got a lot of strategies like the knight. I can't remember the name, but there's a lot of you got the rook strategies. Like all the ones you can use. Those are fragmented. They're fragmented by design because they overlap. Because the attack dimension overlaps with the defense dimension. You don't have a perfect attack. You have something that's an attack but it's doing defense at the same time. Or something that's a defense or offense doing attack. Vice versa across all dimensions. What dimension really game theory? Oh, it's my. Oh, this is recording. After sure it's recording. Okay, yes. What dimension game theory really gives you? Is a solid framework for isomorphing those algorithms in the attack, defense, and offense, and creating new dimensions that resolve with a directed acyclic graph. So you can perform each dimensional and evolve the dimension in new threats or new instances, new situations. That's the first foundation I want to give you. Okay. Let's continue. Content, the big idea, the big picture. Now, the big picture of dimension game theory is never to dimension classic game theory. Then the big picture is what from in layman's terms is to give you the dynamic strategies. Dynamic real world dynamic. Model that. It's a model real world systems. Real world games. As dimensions. These are called dynamic algorithms. Or call them evolutionary algorithms. Because they evolve with human cognition. And consciousness. New human exploitation. I call them evolutionary strategies. These strategies evolve based on new information. What we learn, the enemy do, or what something do. It's about ensuring that the system and protect actually has a goal. And that goal is based on dynamic adaptation in real world context. It allows for you to be authentic in your expression of a game theory, without being bogged down with static linear systems. That grow out of linear bound complexities. Let's continue. Now, go to test the discussion. Go and look at the big picture. Now, we're going to use data projection. We're going to use DK security, advancement, algorithm core, and the robot applications. Okay, guys, let's go. System integration, and take on where you're close. Context. This first context. Okay, part one, the big idea. Okay. Dimensional game theory, the science of perfect strategy. Okay, okay. From chess to algorithms to hacking Unicode, a framework for competition. You know, okay, basically, this I'm saying to you, the chess algorithm and Unicode hacking are the same. This competition, red boom to it doesn't matter in the real world strategy. You're gonna have enemies, you're gonna have people who wanna infiltrate your systems. You can model a perfect algorithm in one dimension, but you can grow in a creative bias in other dimensions. You can neglect other dimensions. You may think the algorithm is perfect, because it only does one dimension, also should attack, but doesn't do the just defense, but it's offensive ways to exploit the defense. This is what dimensional game theory really has to address. the the balance of entropy in the system in the real world, the balance of the system. Okay. The limits of classical registry. Okay. Static and rigid relies on fixed payoff matrices and equilibrium concepts that struggle with dynamics real world complexity. You know, this is a big thing, a bad thing for the classical degree. Classical degree is too static, it's too rigid. Every input has an output, but that input never evolves. My business adoption evolution. Tell about this. So basically, the fixed payoff is like basically, it's like if I have someone knowing what I'm doing, in the real world, I know what they're gonna do too. So if it's a tie, if it comes to equilibrium, it's like a tie, it's a tie. I know. Then I start looking at my, it's 50-50. Then I risk it or lose it all. Then my head, I'm thinking psychologically, should I risk everything? Because this guy is onto me, and the other guy's thinking, yes, I'm gonna risk everything. And then it comes a tie. Or on the other case, it becomes the worst one. They don't risk anything, and they both lose. Because there's no clear distinction between who's gonna who's gonna win. Because the game is the equation, a tie or equilibrium anyway. Because that's the model of the chess anything. The thing is, it fails to come new paths are traceable. Basically, there's new algorithms, new ways of doing stuff. And there's many ways we can come up with scenarios to problems using other theories. Other scenarios. They can analytically do it, or they can use adaptive algorithms to create new solutions to the problem. Real complexity is a big thing, but dimensional game theory addresses that using dimensional models of that strategy. We need a real three and practice. And that's the limit of ground supervision. It's too rigid. It's too static. There's nothing. You can predict input from the output. It's too mathematical. It's too slow. It's not slow. It's slow, but it's too boxed. It allows you to. The structure is too rigid. There's no flexibility even for the user who wants to stay in that framework, because the classical game theory does not adapt for their context, because the inputs never are never more vectors. They're just dimensions, just single layer dimensions. That's what the classical, just single layer, just scalar dimensions, only one input. Strategy dimensions as an axis of play. Decomposing any GUM into dependent non-overlapping axes. Each dimension can be optimized separately while contributing to global coherence strategy. Basically, it's like a sound mixer. You don't have to you don't have to you don't just have the volume. You have the bass, treble, and mid range. This is what I'm saying. You have basically it's like a sound mixer. Each dimension represents a purpose. Like a master volume is just for the volume, but you can tell the bass. You can tell the treble. You can tell the mid range. All the songs that make the sound more in tune with the environment. The thing about dimension equilibrium, once you analytically express those things as individuals, as core individuals, like there's no thing about it. The game is here strategic. It allows for flexibility because the dimension are isolated, they're independent. And the independent don't overlap over the axis. The dimensional axis, like attack algorithm is not a defense algorithm. A defense algorithm is not the offense algorithm. Offense algorithm is not a formation algorithm in chess. Accessory good dimension algorithms, how to organize the best structure to get the perfect game and not all overlap them. Okay, the perfect game theorem. In the zero-sum game, with perfect information, if both players employs optimal strategies, relevant dimension, the game will result in a deterministic tie. That's the truth. That's the truth, guys. Guys, this is no joke. A non-lie outcome to prove a strategy imbalance. This is a signal we can exploit. A corollary. What's a corollary? A non-tie outcome is proof of strategy imbalance. This is a signal we can exploit. That's a corollary. It's not an axiom. It's like it's an axiom, yes, but it's a starting point for addressing this perfect game problem. Because if my enemy in chess plays perfectly game, and he plays perfect chess, and I play perfectly too, the game is a tie. It's a tie. The game will always be a deterministic tie, DFA tie. No, not an NFA tie, unless there's nothing there. I don't talk about NFA yet. NFA illusion, but it's a DFA tie. It's just like the system understands you play perfectly. I prefer the game. It doesn't matter what the game was. And that's why the perfect game theory matters. Now, the theorem is true. It's like Pythagoras theorem is true. It applies to all games in any dimensions. Whatever you do. But the corollary is, if we have a strategic imbalance in any of those dimensions, I play more of an attack. He plays less. Basically, if I play a perfect defense, and then he plays a worse defense. Not so perfect defense. I can capitalize with my attacks. Because there's an imbalance in the defense structure of his, or vice versa. It doesn't matter. This is what I'm saying to you. Okay. DAG, so basically, directed acyclic graph architecture. There's no overlap. Now, the directed acyclic graph is a structural backbone. In short, dimensional computation are independent of flows logically, preserving overall strategic coherence. Basically, the DAG framework is like, and can try to do the cost function Hamiltonian or Eulerian cost function DAG based on real world estimate. But to get to the goal, it's like it's like something in the real world is like trying to system trying to achieve again its objective done in time, but the time is not the goal. It's the its time is not the goal. It's just like a traffic, but you have to check the road BC, for example, and then go down. Say it's like G. Because I can go like basically I'm going to A to T. Basically, this car can't go there 80, but it has to go the other way. So you have to estimate the cost of this road, and that road in the real world preserves the logic A to D. But it's going to E, but goes ADE, but but there's an imbalance. So you have to go A. You shouldn't go A. You can go A here. It just depends whatever is shorter for it. What is shorter road based on the traffic cars, the jam, what it knows about the state. That's why the DAG actually is very important. There's no overlap. There should be never overlap in a DAG structure. Because it's not a coherent DAG. Unless the system doesn't allow for the path to go. The directed edges can represent the cost of the nodes. It can basically make a cost to get A to B. A to D. But if there's any deterrence, which is worst case measurement of the DAG structure for the dimensional game, to employ new strategies to go from A to E or whatever is available in that dimension, as an optimal log n space. The computer graph is log n, is half time space, because the space is like the space of the storage. It doesn't, that's the thing, it just stores the algorithm. It's log n, it's auxiliary space, but it's like, the function equation of the log n is half the time. It's never linear, so you can cut any problem in half. And that's what I'm claiming here, because the dimension game theory is independent of it's independent but flows logically via the directed algorithm resolution. Can just correct an attack, defense, and offense algorithm, or gain a new formation system. Oh no! Sorry guys, sorry guys, I got interrupted. Sorry guys, I got interrupted. Sorry guys, I got interrupted. The turn is playing. Yeah. Okay. So guys, so basically, you guys didn't want guys to hear that ad. Sorry guys, I didn't want you guys to hear that. So I'm saying to you, the term is saying about formation. You have a new formation dimension. That can represent chess formation, or something, or car, and the formation breaks. The formation breaks down. They have to get someone else, there's a new AI system, or a new car to join that formation. And that formation has to realign with objective. That formation is now the chess. So whatever the car is doing, the chess or car, getting to the objective, that has to go, to ensure there's no delay. That's what I'm saying about the cost function and the dagger of the graph, because the piece of the car is not missing, but someone is scalable. Dimension theory is naturally scalable in the real world. This is the term I need. It's scalable. You can scale it isomorphically with peer-to-peer bar string topology, which are forthright models of topology structure for real-world context. Dimensional game theory presents to me the real-world applications of computation in the systems that resolve autonomously without any humans. Doing this, because if I order an Uber and Uber is a robot, a robot, I should get that Uber. If I'm a premium member, but if I'm not a premium member and I still need an Uber, I need to get an autonomous Uber and get that Uber still, because all the premium members still have and there should be no problem, because I am entitled to that service, I can get that car and I can go, that's what I'm talking about, the cost function and the directed acyclic graph resolution for the real world cost function metric to ensure 95.4 coherence over functor composition, which is the cars moving in the real world over terrains and places to go. Okay. NFA function model. Plays are modeled as a non-different finance automata. NFA. Okay, basically, plays are modeled as non-different finance automata actors That means they have ability to act on a decision. Whether they see exploit or something in the real world, they are actors. That means they can act. They're not so much finance autonomous. They can be. They can be, but the actor model is like, if I have an insight in something, I can still win it. If but it's like a plain dimension. I can say it's an NFA resolution. But the thing about NFA is like it's there, it's not going to find item, but map transform into state action. The allows algebraic composition and models complex not basically the actor model is more of you acting on your own behalf on your code, autonomously. You're autonomous and you're in NFA. It reminds me of delay, deny, and defer. The defer is one dimension to deny, or deny to right housing. So I can get denied housing, and the deferral is go somewhere else, and deny is go. The defense is like we didn't do anything. It's not our fault. You didn't sign up. That's the algorithm. Now, the NFA resolution is key to this because that's two endings to it. If I said the search go somewhere else, they defer me, I'll lose my housing. And if they defend their business, and I say no to them, you can't. So it's my fault. I'll lose my housing. What I'm saying to you, delay me, waste time, go somewhere else. Deny. It's not our fault. Deny. That's just real world algorithms. Delay, stop, waste time, a lot of time. Deny, say no. It's not a job. It's not a responsibility. Defer, go somewhere else. You know what I'm saying? See, the NFA function can resolve this DAG function, because the function is a mapping of function, So if I want to defer someone or deny someone, which is an illegal entrapment, I have to say, okay, I have to make it them understand DAG solution, make it implicate them, but it must sound coherent, to be coherent and to work, it has to make sense, and that's where the function of mapping of function model come in. Which can act on their own behalf. Now, syntax over structure. Basically the structure of the system, it's like how the system understands itself. The structure over the syntax. The core method is better structure or obedient success rules. The syntax is just rules. The code is just rules. But if the structure of that system is based on basically the syntax is not a structure because the structure is like the architecture it's built on. But if that syntax doesn't align with the architecture, there's no meaning. You cannot get a system to do any extra. So you build for the structure you're building, the architecture, the infrastructure you're building before you jump into the code. The perfect game algorithm emerges when structure reflects through understanding. Guys, structure is more important than syntax. No matter how you think about it, the structure of a data structure, or the model or something you're building, how you model the real world incident, and how much clarity you have in that model, as a foundation, of that system. It's over the structure, over the syntax, over the analytical framework, it's more beneficial because it's like security. It's like my housing thing. Security by design. If you can design the perfect ring topology and the compound, and you can live in a moat. No one will go to your moat, because there's a shark and then you can get your moat, but the structure of your moat in the compound allows you to get in and get out of your home. But the structure of the topology system is that that you know how to get to your house, as a security measure, but they can't get in because the structure refers you to as a perfect security of like the perfect algorithm. Because it's like designing the system to your house to be naturally hostile to anybody's intruders. Without listening, because it's not trying to get your house down, just to get a helicopter or something like that to get to your properties, but it's not feasible. You know what I'm saying? It's not easy to do. It's feasible, it's not easy to do. Part ends. There's class chess construction. Case study: the perfect chess engine. Okay, now dimensional game theory decomposes chess into four overlapping structure functors. Each outputting a four vector ability, semantic relation. The attack dimension, capturing threat, king, pressure, tectomorphous. This is like an attack, how to get capture, the defense, protecting kings, pawns, structure, escape routes, and then offense, spacing, piece activity, initiating. The offense is more analytical. but you can use the offense to your advantage. But all this is athletical. You just have to solve the problem. Formation, coordination, harmony, coherence, and mobility pattern. That's the formation, like ensuring that you risk a pawn. Do something, you risk pawns, not the full a full rook or something, or something that can, the bishop or something like that can, or the queen, or something that the knight, something that can be used in another context. You create like some kind of defensive framework. It doesn't have, doesn't know what you prioritize per se. But can prioritize or attack what you want. But when you're lacking in any of the other things, there's an imbalance. There's a directory acyclic graph imbalance. The system will fail ultimately, because you neglect all the other ones. You have to think strategically, and you can add another dimension if you want. The thing is like the only actually this dimension, they never overlap. They never overlap. You can create a new dimension or whatever you model and add, but it should never overlap. Okay. Attack and defense, the core tactics. Now, attacking a algorithm, defense, basically this is an algorithm, FA, function A, function A, or function D. Now, this is F, the defense, function for defense. Detect immediate captures. This like be pawns, rooks, analyze speed threats, compute king pressure, identify tactic motive. The motive is like the payoff of like what the enemy is trying to do, but I'm gonna exploit that with an attack. But can be attack the terror motive here. But this like algorithm can be here, because these are like just functions you call. You can add inputs, which is the pawns and everything, but the organize the analyze piece projection, evaluate taking safety, assess pawn structure. These are dimensions, different dimensions. The four disjoint, future additions. These are set models. They're disjoint sets. They're not union set. You can unify one dimension, dimension, but never unify them. Or keep the dimensions isomorphic to themselves, because these are problems you solve in one dimension and not the other. You don't need to, basically, you don't need to fragment the system. There's no fragmentation whatsoever. Uh, okay, offense versus formation. Now, offense is about long-term pressure, space control, piece activity. It's about slowing the enemy down. Slowing your defense down, or slowing whatever piece. Offense is more strategic. It's about the slowness of the system, trying to control this design or what's happening on the board, but it's invisible. It's like there. It's like before you know it, you lose a piece that you don't even know. But it's about picking the right fights. And ensuring long-term sustainability of your system. Function is the harmony. It's like coordination is like there's like a basically I can circle a pawn, but if I circle a queen, this formation is not good. That means the formation is not good, because there's a strategic imbalance, and I couldn't keep my formation. That means a terrible formation, because the formation doesn't allow me to do my strategy, or do what I'm gonna do with my formation. Because if formation is intact, the pawns can be lost, or I can use all the pawns, all the little pieces, and keep all the big pieces in the game, as a perfect formation, because there's a perfect formation that resolves that. And the offense is like the space control, making the enemy weak, and making example of the pieces the moves, and exploiting them psychologically. Red blue players. Basically, this is like more. No, 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 no. This is a change in the PR probability R. First of blue players is 0.6 to, because this is an imbalance vector. This is some 7 minus 0.7 minus 1 is 0.6. The largest probability of the attack dimension signals a clear strategy advantage in red. Because these dimensions represent attack, defense, offense, and formation. That's what I'm saying. Can use a probability scale, and ensure that this strategy is coherent and can be reused. It's a perfect strategy, because the strategy event is a model of vectors in the real world. And that means the blue team, which are playing too defensively, are prone to losing the game ultimately, and they will lose. They lost, even before the game started, because the analytical framework for defensively model over defensive over any attack aggression is imbalancing in the metric. 1 to 1, like the 0.1 here represents here, so basically 0.7 or 0.1 represents attack, 0.2 represent defense, or 0.6, 0.2 in red, probability of 0.6 in blue represents, so basically 0.7 minus 0.1 is 0.6, and this 0.6 is PR minus PB, and this is probability of the red over blue attack versus defense is more over the dimensions attack, defense, offense, and formation. These are just 4 dimensions that I also made using different dimensions, but they're not modeling the problem. And this is the balanced vector. This vector, this triangle sign, I don't know, the change in this means the change in the probability of R, can be measured in real time. That's what in the runtime in the robot, it's a metric for defense coherence, how good your dimensions are doing, how good you are. Detect, identify opposite strongest dimension, neutralize, assign negative weight to counter it, redirect, shift focus to adjacent dimensions, output the bending strategy vector. So I'm saying to you, so basically, it's like robot, you live and you learn. So basically, you're doing strong opponent's dimension. That's your worst case scenario. You don't want that thing getting an advantage. Neutralize the weight, negative weight to counter it. So basically now there's a more balance for you. That's the queen in the case, but redirect, shift focus to adjacent dimension, and that's like the next worst problem you gotta do it. And the next one is like output the blended strategic vector. Now the blended strategic vector is like the executor of the vector in the road, but it's like so it's get 1 detect, 2 neutralize, 3 redirect, and then that new forms a new puts a new dimension there and gives you a new probability score, and that balanced probability score has to be remeasured. And that's after that's when the execution is taking place. That's why it's real time. Because you execute it, then you go a new dimension. But a new dimension means that this variables are updated. Now I'm looking at the same thing, but in a different context. I have different objective. Using this, and I'm saying to you, that's what the balance is measuring in real time. Okay. Now Unicode security 3. Now, case study, apply structural syntax to cybersecurity. The problem is multi-encoding of the same vector bypass relational files. Direct dot, encoded. Basically, the encoded format, the declaration dot. If I type this on a terminal, this encoded format. Now, the UTF representation is problematic. Because these are traditional bypass filters. Because there's I can use this structure of syntax to cybersecurity. The problem, multiple path encoding of the same attack vector, bypass relational filters. So this, I can put in this UTF-8 model of this encoded state, and this will be, I can encode this in UTF-8, but this was encoded in the computer. This is direct one. This one's going to the computer. Dot O2F. Every character. But this UTF representation. Now this is an attack vector. Yes. It's an attack vector. Because UTF-8 is non-canonical. This attack vector is the same as this. I can punch this in. Or write a computer program, and I can bypass the root access. Dot. If dot is current direction, or dot slash dot is like this one. But this UTF-8, because the system doesn't understand, doesn't take this input, it takes this input because this is the encoding of the UTF-8 system, which stands for Unified Unicode. It's a Unicode format of 8 bytes of memory, 8 bytes, 8 bits equals 1 byte model, which is called UTF-8. Because it comes 8 times 8 is got 64 bytes, I think. Yes, I believe so. Isomorphic reduction. So basically, isomorphic reduction is a concept. I take a state, different encoders are just different encoders are just different paths to semantic states. We collapse them into a still canonical form. The canonical form is just the simplest model that's used for the standard application of real-world systems. Canonical just means universal, but it's the simplest form of the universal framework. The canonical form is it's like ensuring that it isomorphic bugs, isomorphic reduction of states, of the states is canonical. It's a feature, not a bug. It's a feature. It's not a bug. You have to reduce all the code, all the encoding, all the second, to ensure that you cannot route out of your frame of reference with any interface system provided by the user or the hacker. Anyway, state CIA. There's a fly here. A timer. Stop flying me, fly. So basically, state side flash time. That's what I'm saying. Using UNC algorithm, a 3-phase 500. Recognition. Classical inputs are by encoding style. 2. Map out the equivalent state in canonical form. 3. Apply it for a single unified security policy. You know, the thing about this is like the recognition of the UCN Unicode security categorization or normalization. Normalization means like the smallest form. So kind of code is just like the simplest one. Of course, the normalized like one system can be one system, but normalized form is kind of code form too. And then this is the Unicode structure, kind of code normalization algorithms, a three-phase pipeline. You know, the result of this one requisition classified inputs by encoding type. Uh, and then two, reduction, map all the way to canonical form. And then three, validate a single unified security policy as part of a phenomenological engine principle as a protocol of the system that's a log n. Now, log n is because if you have an n, someone can have something an algorithm running at n2 log n. But if the log n finishes file goes faster and validation is first, before the linear time algorithm, there's no need to validate because the linear time algorithm will have to take more time than the log n, because the problem have results a logical declaration of encoding based bypass with a systematic reduction in passing time. The copy doesn't need to pass nothing. It needs to run the code. That's the idea of UNICN algorithm 3 pipeline. Okay. Now, USN production metrics. Now, processing time 67. Okay, processing time 67. 4.40. Seriously, for 5 minutes to 15 minutes per request. Every request in your server. False positive 23 to 0.3. It cuts down the order per or the legit false positives over through positive, false positive, through negative, false negative. The false positive it says failed, but it's basically the false the true the third correctly identifies positive false tests that are false, that fail, and that goes to 0.3, and the bypass is 0. You cannot bypass the system because the system understands that it's coherent. It doesn't need to track what it doesn't need. It just removes that. It's like it doesn't need to follow a direction of a path it doesn't need, and that's the production world of it. And then you get advanced mathematics, part 4, mechanics. Now, a very strategy games that evolve. Okay, now we're talking about evolving games. Now, in dynamic systems, new dimensions can lock conditionals. Conditional. It's like an if-then policy. New dimensions can unlock conditionally. A simple input can promote new entire access of strategy. So what I'm saying to you, in dimensional games, you can have a fragmented system such as uh, something called attack defense. But those two are something we don't know. Sort of, you just call it objective. Attack and defend this, attack this objective and defend this objective. But that's not as much, So we have to separate them, by definition. You have to formalize how that dimension, what attack means, what defense means, as a separation of concern. The goal of this various system is to ensure that each system is coherent because there's no ambiguity in the formalization of the dimension. It's like me. I tune a radio, but I need to find the right channel. I have to go through a lot of noise because I can't skip it. This is based on a wave interference. How the silence was like for what the hertz frequency. I can keep turning so I get the hertz frequency to do the channel. I can't just like turn it to one channel in a linear way. Because the system is not allowing me to do that. It's analog. It's an analog signal. It's not a digital system. Because it's a digital system. Yes, but it's not interpreting analog properties. If the two stations were digital, if everything was digital, I can just press a button. I don't even need the dial. But the dial is there because the system is analog. And the stations might get better or worse in the analog model. Because everything is analog waves anyway. So the thing about it is you have to think about it in the real world context. Various are the games that evolve dimensions and planes and models and structure. Think about the structure. It's like me. It's like all these buttons I see in the aeroplanes. There's no point of them to me. They're just buttons that you can use, but but you don't need all those buttons because you just control the plane. You can basically I can put away the sort of buttons and just fly the plane. But it's for emergencies, and that's why the system is for good. The thing about flying plane is dangerous. You gotta get experience, but you don't need all that experience to fly a plane. All you need is to get a steering wheel and the thing and the chair. Sit down on the chair and push the right and ensure the flight ascent and descent is coherent in the weather pattern. That doesn't really mean the everything about the weather pattern. The weather pattern, and model that dynamically. You have to be ensuring the weather pattern is correct for you to fly that plane in that vicinity at that time, at the altitude. And this can be just dimensions or dimensions to think about. You don't have to think about the other guy doing anything or someone falling asleep. You have to think about what am I doing? Doing talking this guy. It's fine. I need to think about myself in the sky, how I go through here. Now, witness ledger and CFI framework. Okay, a equilibrium ledger is source receipts for retraction. Question order body trade. A ledger is something that holds and stores and processes authentic interaction. It doesn't basically the goal of a ledger in my framework is ensure that they do their job, but they're rewarded for doing the job correctly. I'm putting the first, the coherent speech integrity, the CRFF, the coherence of the system is 95.4. Before all the witness ledger and the C is like a structural violation of the QA score gated metric for the whatever the human wants to do or whatever the system wants to align with their own objective. Now algorithm core. Now algorithm dimension detection automatically discover the strategy imbalance of competition. Am I? I don't know. I think it's recording my voice. I don't know. Okay, I hope it is actually. Okay, yes. Okay, I hope it is. Okay, automatically discover the key okay, principal composition analysis. PC collect historical data point outcomes. Compute features vectors for each pair. Apply PCA to principal components and explain the most strike the most significant components as new dimensions. These are all data patterns, but the data patterns must be coherent to ensure that something there means something, there's something we can do about the system. It's like a model, linear model. If the function grows, are we gonna grow that function? Are we gonna exploit that function? What does this growth mean? It's more analytical. Let's cut a diagram. Now, the algorithm is the strategic adaptation. You observe, you detect, you counter, you execute. A closed loop. Everything is a DAG algorithm anyway. So observe opponent move, detect dominated general counters, and blend algorithm strategies. And blend strategies. Doesn't mean try to use both strategies. Do an attack then a defense in a sequence. Basically, you can try to do attack defense in like a sequence or series. Or a section, which can resolve over the system adapts and reward as an actor model. If you're the one playing the game as yourself, you can act, observe, and consume. Act and mutate state based on feedback loops. Now, reward domains. Okay, now application financial trading. Now, financial most of basically domain strategies. The thing about domain strategies is that's new algorithms or domains, but these domain scrums have a flaw. They're domain to one domain and not domain to other domain. Because they only think about what the money is. The algorithm doesn't adapt to real world banks, building societies, everything. It doesn't think about the real world flow of economics, which is what is the organizational differentiation is fluid. The thing it's about among the recs of the management system to ensure the system is asymmetric working for you. Now, application automation system. Model other vehicles as strategic agent with dimensional profiles. So look at woman. Look at woman. What women like in cars, autonomous cars. What the woman need in normal cars? It thinks about the consumer and how they want to profit from the using predictability of the trending status of women with the status quo. Women as a kind strategy to mitigate. Say I want to make my own cars for women. Because women are vulnerable, more vulnerable than men, and they like smaller car, bigger cars. But they want bigger cars with security. I think about the security aspects for women. What women consider secure and luxurious, and how that blends into their own unique flair, owning a brand or car. This I'm saying. The model of the driving system must think about the dimensions, involve, across what I'm marketing, what I'm aggressively marketing, risk what I'm marketing to women, or marketing to a need, like a brand for some lady. Think about the woman, and then you can get the car too. Application, just one example, but that's really put that there's something else. Okay, application, cyber physical business. Now, cybersecurity, identify attack, brute force, social engineering, dynamic allocate. These real world attacks can be modeled as bioinformatics informatics. That's a mission of substrates or subsets, across dimensions. You can create new dimensions to identify new problems, new accesses. But are these dimensions we have to add? Are we being misled? We have to take in threat patterns. They're called threats, is my understanding misaligned with my objective? Am I being mitigated with that technology? Now, business competition. What do business competitions along the mention like price sensitivity, quality? The cyber physical and business. It's about ensuring there's a competitive edge. Uh, Reward adaptive as a reward adaptive reform, adaptive algorithm evolution algorithm reform resolution over that pressure. The brute force solution is time to offense counter threat patterns. Because cybersecurity, the threat patterns are new ways that people can exploit systems. But they're social engineering because the computer can't detect this, can now enforce social policies as in varying clauses, ensure that things like brute force, which is like algorithms that literally like a force its way into the system, and social engineering, the code coming to business and trying to exploit someone, it's time resource and counter detection patterns. How does patterns, how does exploits work in the business model? Because in the ecosystem of that business infrastructure, whether it's a human, whether it's an AI system, doesn't really matter. It takes into other dimensions that can't be accounted for programmatically. Just naturally with a computer. If a computer is just doing it over the internet. Yeah, systems moderation. This is like a hypertext instruction system is a polyglot runtime for DGT algorithms involving basically all my computers are really for torrent coherence traffic. The image is severe hotspot. It's like OpenXS Sumuko Holo. Holo, which stands for holographic technology. Now, in my framework, the HTTP architecture is like observer consumer and ensuring that the holograms are the minimal for the worst ones that can't use it, the children. There's a rebuild for them, for the adults when they grow older, so it sustains them. It sustains them forever. So if I buy something when I'm 10 years old, I can use it while I'm 40 years old. 4 years later, 40 years later, times four, 10 times 4 is 40. 40 years later, I'll be using it. The same thing, or 50 years, you're gonna, because if I buy something, 40 divided by 10 is 4. 4 years, if I buy something when I'm 10 times, 4, if I won't get something when I'm 4, if I won't get something when I'm 4, I can use it when I'm still using 40. There's no limits, because the disease algorithm preserves me, using the philological legend principle as a protocol in that system architecture. Now, future DDT plus quantum coherence. The frontier of the research extent of DGT functions into quantum states support higher order dimensional interactions. What does that mean? Now, quantum coherence is the model of the system being like a plasma coherent system. How can quantum system be stable when dimensional game when they are analytically modeled with dimensional game theory? Yeah, like we have to resolve all the physical laws and research hypothesis, ensuring that the DGT is just not it's meant to, as part of the variance course, because it's about ensuring that quantum systems are implemented such as plasma system, like the one for the brain computing phase, and can decohere silent without killing everyone, or ripping a through space time, and something like that. Because it's about ensuring the DGT plus plus extensions is coherent and it does the job according to what is set there in the standard without complicating the whole system. Because DCC is about coherence, not decoherence. It's about ensuring we can mitigate decoherence from coherence. In variance. But because that's on everything decoherent must be as a very possibility of the quantum state of the classical or quantum states. Modeling. Takeaway and close. Now, dimensional game theory core principles. Decompose games into structured dimensions. That's what are the dimensions formalization? What does that mean? What is this dimension doing? Do I even need it? Am I being misled by my other friends who create dimensions? Perfect play. Tie imbalance opportunity. Perfect play equals tie. Imbalance equals opportunity. That's my insight. That's my information. Because I have an edge. To do something. And it's not just a risk reward. It's a mathematically verified risk reward to mitigate a risk. Push the enemy. Gain advantage over something. Now the enforced non-violent structure with diagonal telegraph. Practice structure. The structure of the system, the formation, the logic, the structure, how the system was built, designed over the semantic instruction. That directs symbiotic evolution. How system can keep its coherence under pressure by ensuring that the priority of the structure is not against itself, system against them. And what weird weird semantic reduction as a weirded as a, this is like a resolving problems into the canonical form, across all systems and coherence. These problems are the same, but they are over the same different dimensions. They can be isolated from each other. They just it's just like you don't have one problem, two algorithms, one in attacker doing defense doing the same thing. You keep them in one dimension. And that's as somebody reduction really make sure they keep on the old dimension forever, like for all the systems that need to use that algorithm, attack and defend. Now, perfect games algorithm measure one structure fixed through understanding. The structure of the system is a strong foundation of the system. So if the structure system by design is flawed, the system is naturally flawed. Because all these algorithms you see are just measures for that system. Whether it's a moat, the security measure is broken. Because if the architecture is broken, the security measure is not there anyway. Because there's just a measure. It's a measure you take. There's no actual design philosophy for that measure no more, and that infrastructure is just security flawed naturally. This is more than a set of questions. It's a journey towards creating system generally comprehending the gameplay. The structure of the architecture of the infrastructure, how the system is meant to be, has to be kept in the design. With 95.4 coherence, ensuring 100% 4.6 stability across observer attack dimensional game theory continuity of the analytic framework to develop further and further as a core evolution philosophy for real world threats. Okay, now the open research DGT full research press DOI linkages basically the DOS I don't know basically this if you go to github.com/open access peer review can give me a peer review there, as a particular not to you can get pull and you can get clone the open PR repository and then give add as a contributor and I'll try and add you. But dimensional game theory or DGT is a new framework for static mitigation for dimensional algorithms that can evolve and adapt in the real time via actor coherence. The actor able to that means you're an actor, you an actor in the game model. You act on your own accord. You act for your own information. You act for your own dimension to ensure that there's no strategic imbalance over payoff. Guys, thank you very much for watching. Share, like I said, subscribe. The link is there. If you want to see all my links, go to my youtube.com /@ O for Oscar, B for Bravo, I for Indigo, N for November, E for Echo, X for X-ray, U for Umbrella, S for Sarah, and then and then click see more link, and see more link is there. You see all the link, you see my TikTok, everything. But guys, thank you for watching. I really appreciate it. This is Obit Namdi signing out. Have a lovely day. Now that's Dimensional Game 3 in a nutshell. You can try to go to the paper and see how the paper works. The attack vectors and how they resolve the system. I want you to try and solve a problem in any game. You can try Go, which is Chinese board game Go, and as a more analytical framework to ensure the system performs adequately in the real world scenario. Thank you.